Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the three compounds from their skeletal structures. Structure: a bow-tie shape, 2 triangles, cyclopropane rings, connected at a single central carbon is equal to spiro, 2.2 pentane, C5H8, molecular formula. Structure: 2 triangles forming an X within a rectangular outline. This represents bicyclo, 1.1.0, butane, C4H6, 2 cyclopropane rings fused sharing a common bond. Structure: 3 a diamond shape with an internal vertical line, 2 triangles sharing one edge is equal to bicyclo, 1.1.0, butane. Re-examining, the diamond with a line down the middle represents 2 fused triangles sharing one side, which is bicyclo, 1.1.0, butane, C4H6. However, comparing 2 and 3, 2 shows an X pattern suggesting bicyclo, 1.1.0, butane, while 3 shows a simpler fused bicycle. Actually, 3 with the vertical line in a rhombus is equal to bicyclo, 1.1.0, butane, and 2 with X is equal to also bicyclo, 1.1.0, butane but drawn differently. Let me reconsider. I is equal to spiro, 2.2 pentane, C5H8, 2 is equal to bicyclo, 1.1.0, butane, C4H6, with X showing all bonds. 3 is equal to 2 fused triangles sharing edge but simpler is equal to also bicyclo, 1.1.0, butane or cyclopropane dimer. Moving on to the next step. Assign molecular formulas and heats of combustion. I. Spiro, 2.2 pentane, C5H8. Heat of combustion depends on molecular size and ring strain. Larger molecule is equal to more heat released. 2. Bicyclo, 1.1.0, butane, C4H6. Extremely high ring strain per carbon. 3. This appears to be bicyclo, 1.1.0, butane drawn differently, but if it has fewer carbons or less strain. Moving on to the next step. Apply the principle that heat of combustion increases with A. More carbons and B. More ring strain. Strain energy is released as additional heat. Spiro, 2.2 pentane, I. C5H8, has more carbons than bicyclo, 1.1.0, butane, C4H6, so it releases more heat of combustion overall. Among the C4 species, bicyclo, 1.1.0, butane has extreme ring strain. The ordering given as correct, I, 2, 3, meaning spiro, 2.2, pentane releases the most heat, followed by bicyclo, 1.1.0, butane, followed by the third structure. This makes sense. I has 5 carbons versus 4 carbons in 2 and 3, so I has highest heat of combustion. Between 2 and 3, 2 bicyclo, 1.1.0, butane has greater ring strain than 3, which may be a less strained isomer. And for the final step, why other options fail? B, C, D, all place, I, lower than or equal to others, or rearrange 2 and 3 incorrectly. Since I has the most carbons and also significant ring strain, it must have the highest heat of combustion. 2 has more ring strain than 3, giving I, 2, 3. Therefore, the correct answer is A. Therefore, the correct answer is option A.